So at this point, you might ask, so what that I can, make someone's font a little bigger or maybe hide their font. But keep in mind that a cross-site scripting vulnerability is not just a problem with HTML. It is a problem that is caused by something that an attacker is able to inject into a browser's context, and that might include JavaScript. JavaScript is a fully functioned programming language, and it does give you pretty extensive control over what you can do in the browser, including accessing data elements that might contain sensitive information or change even the behavior of a website altogether. So if an attacker is able to inject JavaScript into a web page using cross-site scripting vulnerability, he can basically execute arbitrary code in a web browser, and of course that is a bit of an issue at times. And we'll take a look at a few examples of what that would mean. The first one would be a quick overview of what you can do to basically create a full denial of service attack using JavaScript against a website. It's almost too simple to be believable, but I'll show you how to do that. Through JavaScript we can access cookies, and that means that we can read the contents of cookies, but we can also make changes to it or remove them, add new ones, whatever we feel like. And lastly, JavaScript gives you access to all the contents of the page, so I can make changes to things. I can have the page behave in a completely different way than it was originally intended. So those are the three scenarios that I want to talk through right now: the denial of service situation, the problem with accessing cookies, and then lastly the ability to change the nature and the look of feel of a web page. Let's take another look at cross-site scripting, but this time we'll throw JavaScript in the mix. First off, I am using the Firefox web browser for this particular demonstration. Google Chrome has a number of built-in protections that prevent many of the cross-site scripting attacks being successful, so we'll switch to Firefox when needed. So let's go take a look. Let me bring in an editor. In JavaScript, we can access the browser context through the document object, and we can change the location to which the browser is pointing by just changing the URL. So for example, this. Now we want to update that a little bit because we have to tell the browser that we're actually sending a JavaScript. But if we can inject this, what would happen is as the page loads and this script renders, it would redirect it away from my location and would just send it over to the adelphi.edu homepage. So copy paste, let's go take this away and just drop it in here, and let's see what happens. Poof, there we go. Which means that if I can somehow inject this kind of JavaScript into a web page, and that is loaded each time, the web page itself now becomes unusable, and the only access would immediately redirect to it. So I have now created a denial of service attack. Let's take a look at another example. And in this particular case, let me first pull in my browser again. We're interested in the cookies that a browser is setting. First, in order to inject, we have to make sure that we make it HTML compatible. So we're going to say the script tag, and we're ending it properly. Now, let's start by just printing out the value of the cookies as we have them right now. Document.cookie returns a string containing all the cookies we have. Well, let's put this over here and inject it over. Nothing here, but when we go into our add-ons, our preferences, no, not our preferences, we are going into the web developer option and then the web console. We see in the bottom it prints one long string containing all the cookies. Now, if we're only interested in one particular cookie, it's a little bit of an annoyance to get this right. But if we look closely, we see that the cookies are separated through semicolons. So what we can do is take this long string and split it up into an array using the semicolon as a delimiter. And then secondly, within each cookie we see its key equals value pair. So each of those entries in the array we can split up into an array of 2 elements, a key and a value. So let's see if we can figure out how to do that. So let's go take this, we're going to go document.cookie, and what we're going to do with document.cookie is split it up using the semicolon as a delimiter. So that should now give us an array. Cookies is now an array of cookies, but each is still a little string of key equals value. We can iterate over that, and again the JavaScript syntax is a little unnatural if you're not used to functional programming, but it's really not that bad once you get used to it. And at this point we can pull the data out and say, well, each cookie will become accessible to us as C, one at a time. So we're going to do C, and we're going to split that again, but now with the equals sign as a delimiter. And we can now console.log, let's say that we're interested in only the key name, get rid of some white space, leading and trailing, and that should be it. Let's take a look and see what happens if I drop this into my console. And that actually worked. First try, that's kind of amazing. But what we see here on the bottom is a list of cookie names. Now if we were interested in, and I don't know what these cookies are, I did not set them, but let's go take a look for this one. So it's cookie consent underscore status. So let's see if this works. So if data 0 equals cookie consent underscore status, in that case what we want to do is just print out the value. We'll make sure that we're trimming this up so we don't have to worry about white space, and that should be it. Let's see if I'm still getting lucky on this one. And the value printed here is dismiss. So at that point we have a way to quickly run through all of the cookies set in our browser. Let me put the code back on again. So first of all, take the overall string containing all the cookies, splitting it up by semicolon so we can get an array of key value pairs as strings, and then each key value pair we're splitting up using the equal sign as the delimiter. So data 0 is the key and data 1 is the value. It's a little bit clumsy, but hey, you only have to do this once and then the computer does the rest for you. Now, of course, at this point I just console logged it, but I can do other things, and we'll check that in a second. Let's take a look at this situation here. This is the cross-site scripting setup that we've seen before. Whether it's stored or reflected cross-site scripting doesn't really make a whole lot of difference. But let's assume that we're extending this a little bit, and let's say that a evil web server, which is under the attacker's control, exists as well. So now we can have a situation where the attacker injects JavaScript, the victim downloads the JavaScript and executes it in their browser context, but there's nothing saying that we can't then post whatever we want back to the evil web server's context. So at this point we should be able to steal data from the victim. And let's see if we can get that to work. Good. So let's take a look at where we ended up. This time around we're going to keep this exactly the same way, but we are going to see if we can not just log the data to the console, but send it off to a server somewhere. So the first thing to do is get myself a server. I happen to have one, the computer science server. And what I can have it do is just listen on incoming connections for TCP port 3000. So that's going to sit there for a while. Not going to touch it, but I'll pull it back in when needed. Now we have to start changing this, because we don't just want to log this to the console. We want to do some other stuff with it. Now, one of the easiest ways to do this is by creating a new XML HTTP request, which is basically a way to call out to a web server from within a JavaScript program. And all we have to do is at that point say, hey, how do you want to send that information to the web server? Well, typically if you send data up to a web server, you use the post method. If you want to download from a web server, you use the get method. And we'll just go put our host name in there. And notice, let me pull it back in. I am listening on port 3000 here. So that means I have to listen on send it to port 3000 here as well. And at that point, all we have to do is send up to the server our heist. And what are we sending? The cookie we just stole. So let's see if that works. Copy paste and minimize. Let's see if we can get this going the way that I want it to go. Probably not. Let's see, make this a little smaller and this a little here. And so I'm going to submit my query. And I made a typo in my JavaScript, so let me go fix that. The problem is this. JavaScript is case sensitive and the function is called this. So now this should work. Make this small again, put it in here, keep an eye on the window on the bottom. And here is my data coming in. On the bottom I have heist equals dismiss. So let's pull up the code again and run through it quickly. What we're doing is all the same we did before, except instead of printing it to the console, now this time we made an asynchronous request to the server we control, and we're just sending the data that we want, and in this case that data is the value of the cookie consent status. Mission accomplished. We've executed JavaScript in someone's browser, and that person never even knew we did this.